Hi class, welcome to Tal Tutorials. Today we will be discussing class 9 part 1 second chapter known as motion in one dimension. Before going into this chapter, let us know what is scalar and what is a vector quantity. Scalar quantity are those physical quantities which are expressed only by their magnitude. For example, if we say that a mass of 6 kg, it has a complete meaning. That is, we are expressing it completely. We need the following two parameters to express a scalar quantity completely. First, unit in which the quantity is measured. Second, the numerical value of the measured quantity. So basically, scalar quantities are only those quantities which have magnitude but no direction. I have shared you some examples like distance, speed, mass, energy, density, power, area, length, time. They have all are scalar quantities. But vector quantities are those quantities which require the magnitude as well as the direction to express them. Then only their meaning is complete. For example, if we say that displace a particle from a point by 5 meter, the first question will arise, in which direction? So we need both things. Thus, in this we require three parameters to express a vector quantity. First is unit, second is numerical value, and third is direction. For examples, I have shared you like displacement, velocity, weight, acceleration, force, gravity. These are all examples of vector quantity. Now going forward, what is rest? See, if a body is said to be at rest, that means it does not change its position with respect to its immediate surrounding. While a body is said to be in motion if it changes its position with respect to its immediate surroundings. For a moving body, if the distance traveled in a certain time interval is much large as compared to the size of the body can be assumed to be a point particle. In this chapter, we are dealing either as one-dimensional motion or we can say as motion in a straight line. If a body or an object changes its position with respect to its surrounding with time, it is known as motion, as we know. However, if it is changing in a straight line, in one direction, in a rectilinear motion, like a straight road, like a stone falling down vertically, this is said to be motion in one dimension. Now, the next part is uniform and non-uniform motion. The motion which occurs when an object travels equal distances in equal time intervals. Means, as I shown you in the graph, in 1 minute it has traveled 10 meters. In 2 minutes it has traveled 20 meters. So we see that in every minute it is traveling 10 meters. So this motion is said to be a uniform motion. But what is non-uniform motion here? Non-uniform motion occurs when object travel different distances in equal interval of time. For example, in first minute it traveled 10 meters, in second minute it traveled 15 meters, in third minute again 5 meters. So we see that time interval is equal, but the distance which the body is covering is unequal. So that those motions are known as non-uniform motion. Now, what is distance? What is displacement? What is distance? The total length of the path through which a body moves is called distance traveled by it. The distance traveled by a body depends on the path followed by the body. It is a scalar quantity. It is generally represented by the letter S, and the unit of distance is meter. Distance has only magnitude. It measures the actual ground covered. While displacement is the shortest distance from the initial to the final position of the body. It is the magnitude of the displacement, and the direction is from the initial to the final position. Again, the SI unit is meter, but it is shown as a vector quantity, and its symbol is S vector. Vector means arrow sign. The magnitude of displacement is equal to the distance if the motion of body is one dimensional, that is straight line. Now, what is speed? Speed, being a scalar quantity, is the rate at which an object covers distance. The average speed speed is a vector. Speed is ignorant of direction. On the other hand, velocity is a vector quantity. It is distance direction aware. Velocity is a rate at which the position changes. SI unit for both speed and velocity is meter per second. What is the difference between speed and velocity? Speed, first difference is it is scalar quantity, while velocity is a vector quantity. The speed is always positive. It is the magnitude of the velocity, but the velocity can be a positive or negative depending upon the direction of the motion. The average velocity can be 0, but the average speed can never be 0. As I said, both the SI units are meter per second. What is the difference between uniform and variable velocity? If a body travels equal distance in equal interval of time, then the body is said to be in a uniform motion or uniform velocity. However, if the body travels unequal distance in a particular direction in equal interval of time, or it moves equal distance in equal interval of time but its direction does not remain same, then the velocity of the body is said to be non-uniform or variable. What is the difference between average speed and average velocity? Average speed is the ratio of the total distance traveled by the body to the total time of journey, which is it is never 0. If the velocity of the body moving in a particular direction changes with time, then the ratio of the displacement of the time taken in the entire journey is known as its average velocity. Average velocity of a body can be 0 even if its average speed is not 0. Now, I think this is the acceleration and retardation. So, what is acceleration? Acceleration is the rate of change of velocity with time. Thus, acceleration is numerically equal to change of velocity in 1 second. Acceleration formula is change is velocity by time, so its SI unit is meter by second square. CGS unit for acceleration is centimeter per second square. So, what is retardation? It is just the vice versa of acceleration. It is the decrease in velocity per second. If someone tell you to differentiate, so acceleration is the increase in velocity per second, while retardation is decrease in velocity per second. Thus, retardation is nothing, as I told, it is a negative acceleration. In general, acceleration is taken as positive, while retardation is taken as negative. Now, we'll come to the last part, that is acceleration due to gravity. See, when a body falls freely under the gravity, the acceleration produced in the body due to Earth gravitation acceleration is known as acceleration due to gravity. The average value is always taken as 9.8 meter per second square. But in numericals, if there is no value given, we are taking as 9.8, but somewhat you will see 10 is also given. See, the value of G does not depend on the mass of the body. Hence, if two bodies of different masses are simultaneously dropped from a height, both will reach the ground simultaneously in vacuum because there is no effect of friction or buoyancy due to air. The value of G varies from place to place. It is maximum at poles and minimum at the equator on the surface of the earth. This is end for this PPT. In the next PPT, we will be discussing about the graphs of the this chapter. Till then, bye bye, and we will meet you